The next question is, assume that X and Y are members of a set B. Show that this set, the set containing X, and containing the set containing X and Y, is in the power set of the power set of B. Now, this question is a bit daunting at first hand. It just gives us very little information to go off, and we have two power sets working together, so it can be just a little bit intimidating, but it's okay because we're gonna work through it slowly. All right, so the first thing it commands us to do, this question, is to assume that X and Y are members of a set B. So just right off the bat, we know that X is in B and Y is in B. And we should just take that to be true because Anderton decided this was the case. Okay, now how do we even show that this thing is in the power set of the power set of B? Like what does that even mean? And how would we ever figure that out? Okay, so we just have to remember what the power set of any set is. So let's say S is a set, as usual. Then the power set of S is the set of things, oh my god, X such that X is a subset of S. That is our definition of what it means to be a power set. And so we equivalently can say that X is in the power set of S if and only if, all right, I'll just write it out, if and only if X is a subset of S. Okay, so that gives us a bit of a foothold. It gives us a bit of a start into how we might be able to show this. So to show that this comma xy, I think this is the set, yep, is in power set of B. It suffices to show that this set is a subset of the power set of B. And yeah, okay. Now, how do we show that this is true? We have to go back to the definitions again. And, most of the questions in chapter 1 of this book are not, how would I call this? They're not difficult because they make you think too much. They're difficult because they just require a lot of tedious work. So, this is a subset of the power set of B if and only if this thing is in the power set of B and this thing is the power set of B. Why is that? Because to show that this is a subset of this, then we have to show that every element in the left-hand side is also an element of the right-hand side. So we show that this set is in the power set of B, and we have to show that this set is also in the power set of B. Okay, cool. Right, so what now? There's just, oh yeah, we can unwrap this definition now. So this set X is in the power set of B if and only if X, sorry, this set is a subset of B. And then this is True if and only if x is in B, which by our initial assumption is true. So this is good. Now similarly, x comma y is in the power set of B if and only if x comma y is a subset of B, is if and only if x is in B and y is in B. Now is this true? Yes, by our initial assumption, once again. Okay, so now we kind of like built up the proof this way, and we've seen that the very last step is true. So now if we go back up, you can see that everything simply follows. So x is in B and y is in B. Therefore, this, I'm going to use actually a highlighter. So x is in B and y is in B. Therefore, x comma y is a subset of B, and thus x comma y is in the power set of B. Good. Okay, now up here, this line, x is in B, which means that this set is a subset of B, which means that this set is in the power set of B. Now, we proved this is true here, and we proved this is true here. So now we know that this also is true. So this set is a subset of the power set of B. And this means that this set must be in the power set of, wait, what did I write here? Oh, my bad. Okay, this might have confused some of you. But here, okay. I might re-record this again if it warrants it, but it's a pretty simple exercise, and if you've stuck with it to this point, you'll see the mistake. Okay, to show that this is in this set, then it suffices to show that this here is a subset of the power set of B. Okay, so yeah, so we show that this is true, and then we show that this, sorry, and then that means that this right here is true, which is what we wanted to show in the first place. All right, cool. That is all for this exercise, and I'll see you in the next one. Which one's the next one? Oh, this one's pretty okay. All right. See ya.